So good afternoon, everyone, and welcome to this lecture. We are in the second, 12th lecture, I think, of Newton laws of motion, and we are dealing with pseudo force in this lecture. In the previous lecture, what we did was we found out what is pseudo force, what is non-inertial frame. A non-inertial frame is a frame of reference where your Newton laws are not valid. A frame of reference which is accelerated with respect to Earth, considering Earth as an inertial frame, becomes a non-inertial frame. Newton laws are not valid in their original form. So how do we make them valid? We make Newton laws valid by applying imaginary or real or unreal force, which is known as pseudo force. The magnitude of the pseudo force is m into a, and direction of the pseudo force is opposite to the direction of acceleration. Do we remember this, everyone? Yes or no? Now we were trying to do some problems based on this so that we understand the concept of this pseudo force, and this is the first problem that we are going to do, and I hope all of you can get me the answer for this one. Now what do we have here? We have lift a lift is going up with an acceleration a, and then we have a small block of mass m kept on a wedge on the lift. Now, up till now, we have done questions where the block was on the wedge and we had found out its acceleration. That block was connected to a lot of bodies. Sometimes it was connected to one string, sometimes it was connected to two strings and three strings and four. But here there is no string, there is just a single block which is kept on an inclined plane. The angle of inclination is theta, and this entire system is in a lift, and this lift is going up. You have to find out the acceleration of the block with respect to the wedge. With respect to the wedge, what is the acceleration of the block? Now you can understand when and how it is easier to solve this problem. Is it easier to solve this problem from the ground, or is it easier to solve the problem from the lift? Which is an easier thing to do? Solving it from the ground or solving it from the lift? Yes. Which is the easier task? Solving it from the ground or solving it from the lift frame? Is my question clear to everyone? From which frame is it easier to solve this problem? The ground frame, from ground, or sitting in the lift?
Ground.
Where?
Ground, sir.
Ground, sir. No, it is not possible. It is very difficult to solve it from the ground frame. So we will have to solve it from the lift frame, and that is the easiest option to solve it. So you have to solve it from the lift frame. That is easier because with respect to ground, the motion is quite dramatic and it's not an easy one to imagine. So that is how you will do it. You will solve it from the lift frame. I'll give you 2 minutes to solve this problem. Are you trying the question? Yes or no? No one there with an answer? Is it such a difficult question? Okay, let me solve it for you. I don't think you are getting the way to solve it because it should not have taken off so much of time. If you would have understood the concept, it would not have taken so much of time. So let me do it for you. So as you can see, it is easier for me to solve the problem from the lift frame. So what do? I sit on the top of lift, and then the problem becomes very simple to solve it from the lift frame. Now I draw the free body diagram of this body. I draw the weight mg, and you remember this is mg sine theta. The body is going to move along the wedge mg sine theta. This component will be mg cos theta, and this would be the normal reaction. But we have to understand that we are not on a inertial frame, we are on a non-inertial frame, and the acceleration of this frame is upwards. So in order to apply Newton laws, I will have to apply an additional force, m into a. Since the acceleration is upwards, I have to apply it downwards. So if it goes downward, it actually comes in the direction of mg. So the downward force becomes mg plus ma. So this component, since ma is downwards, I have to take the components. This becomes ma sine theta. This becomes mg cos theta. ma cos theta, mg cos theta. And now you can make the equation of this block from the ground, from the lift frame. As you can see, there is no force in the backward direction. There is no force in the backward direction. There is only forces in the forward direction. Therefore, this block will accelerate downwards. How much is the downward force? You can look at the downward force. One is the pink one, which is the real force. One is the green one, which is not the real force, which is the pseudo force. That are the two forces. So to make the equation, how will I make the equation? M into a sine theta plus m into g sine theta, which is the downward force, must be equal to m into acceleration of this block a dash. Remember, this is the acceleration of the block with respect to the lift. So the acceleration of the block with respect to the lift becomes A plus G sine theta. A plus G sine theta. This is the answer for this one. Now, this question could have been easily solved. This question could have been easily solved because the acceleration was right upwards. This acceleration could have been easily solved with one concept, which we say the concept of G effective. The concept of G effective. The concept of G effective. What is this concept of G effective? Now, if a motion is happening in a frame which is accelerated, wherever G comes in place of G, you can use G effective, where G effective becomes the effective value of G. Here, as you can see, normally there should be only one force mg downwards, but here we see mg plus ma. So I can say that effectively the value of G becomes G plus A. Do we understand this? So basically, if I would have substituted, simple thing, if I would have substituted instead of G, the value of G as G plus A, you would have got this answer straight away, because we know when a block is kept on an inclined plane, the acceleration is G sine theta downwards. Here, the only difference is the system was accelerating upwards. So what I did, instead of G downwards, I take G plus A downwards, and the net acceleration becomes G plus A sine theta. So basically the effective G, the value of effective G, you can solve this question by the concept of G effective. You can take the value of G as G plus A, and you can get your answers. Do we understand this? Now, similarly, if this lift would have been going downwards with an acceleration A, this lift would have been going downwards with an acceleration A, what would be the acceleration of the block then? When it was going upwards with an acceleration A, the value of G was taken as G plus A. When it is going downwards with an acceleration A, then what will happen? Instead of applying the pseudo force downwards, I will now have to apply pseudo force upwards. Yes or no? So what will be the value of the acceleration of the block if the lift is going downwards with an acceleration A? Then the answer in that case would be instead of the effective G becoming G plus A, in that case, the effective acceleration or effective G will become G minus A. And then your answer in this case would be the acceleration of the block will become G minus A sine theta. Do we understand this? So if you have this question ever, anywhere, when something is happening in a lift and lift is going up with an acceleration, what you got to do is, instead of G, just use G effective, and you would be doing well. Do we understand this, or this has gone above our head saying bye bye? Bye bye, sir. I'm going.
Sir,
Yes,
sir,
beta.
sir, in diagram you written mg cos theta plus mg cos theta. That is ma cos theta, na sir?
Yeah. It's MA cos theta. Anything else? MA cos theta.
Nothing.
So do we understand this concept? Yes or no? But remember, in all these cases, whatever acceleration you get will not be acceleration with respect to ground. It would be acceleration with respect to the lift. Do we understand this? Whenever you solve a question from a non-inertial frame, you will always get the acceleration of the system or acceleration of the block with respect to the non-inertial frame. Do we understand this? Yes or no? You will never get it with respect to ground. You'll always get it because your reference frame is non-inertial. So you will get your answer from the non-inertial frame and not from ground. Shall we move ahead in life? Life has to move on. Huh? Have you noted this down? Yes or no? No, yes. Huh?
Sir.
Let's see if you can do the needful in this question. Here comes the next question. Are we ready for this? Huh? Now we have this case. We have a spring system. M2 is greater than M1. And this system is kept in a lift. And this lift is going up with an acceleration A. You have to find out the acceleration of the blocks. Let me take, okay, let me make it general. Then I'll give you a special question. You have to find the acceleration of the blocks with respect to the lift. Once you get the answer with respect to the lift, you should be able to get the answer with respect to ground. I'll give you a question where you can get the answer with respect to ground as well. Do you understand the question? Yes or no? Huh? Chalo then. You have the time to do it.
Sir equals to sir. Sir acceleration equals to
Yes. Say. You got the answer?
yes sir. Sir acceleration equals to m2 minus m1 into g by m1 plus m2 sir.
M2 minus M1
Plus m2.
into G upon.
Sir m2 minus m1 into g by m1 plus m2.
So it does not make any difference of this lift going up. No difference there. How that can be the answer? No, it's not possible. Wrong answer. That cannot be the correct answer, beta. This lift is going up. How it can be the same acceleration as lift not going up? Cannot be the same. I hope you understand this. Cannot be the same answer. Okay, I'll do it. So, now trust me, the best place from where you can understand the motion of this block, and that will be the simplest, would be standing on the top of this lift, chilling out, and then making the equation of this. Now, as soon as you go inside the lift, then you will see what you will see, that this M2 block will be going with downwards, let us say with an acceleration a dash, and this M1 block will be going up with an acceleration a dash. That only would be visible when you are inside the lift. From the ground, the scenario can be absolutely different. Then you write the equation. This is T, this is M2G, this is T, and this is M1G. But then you realize, oh God, I'm sitting on a accelerated frame, and I must now apply the pseudo force. I'm going up, so the pseudo force will be downwards. On this block, it will be M2A. On this block also, it will be M1A. So effectively, what happens, my dear friends? What happens what? In place of G, now I have G plus A. G plus A. G plus A. The effective value of G. And now my answers are pretty simple. The value of A dash, which is the acceleration with respect to the lift, becomes M2 minus M1 into G plus A divided by M1 plus M2. This is going to be the acceleration with respect to the lift. Do we understand this, or this has gone above and saying bye-bye, 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 bye-bye? This is going to be the answer, my dear friends. Do we understand this? Okay, I'll give you one more chance to redeem yourself. Remember, students are like cash vouchers. Sometimes they may not work. If you keep on doing it consistently, you might work. Now I'll give you some values so that you understand how the motion is from inside and how the motion is from outside. So I'm now giving you some values so that you can get some answers, and you will be astonished by what you see. This, my dear friend, is the question now. I'm giving you some values. This lift is going down with an acceleration g by 2. You have to find out the acceleration of block M with respect to lift, acceleration of block 2M with respect to lift, acceleration of block M with respect to ground and acceleration of block 2M with respect to ground. Do we understand the question? Yes or no? No, yes. Huh? Do we have anything that looks like an answer? Huh? Anyone got anything that looks like an answer? So this thing looks like an answer. Huh? No one has anything that looks like an answer. Shall I do it for you? Huh? Okay, I can expect that I am getting an answer somewhere. From somewhere an answer is going to come and say, Tapak, I am the answer. Huh? Or shall I do it? Yes, bacha. Or I can expect an answer is coming from somewhere. Answer, answer, answer. Is it coming? Coming, 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 coming. I'm waiting for the answer. Let the answer come. Let the answer come. Where is the answer? Where is the answer? Where is the answer? If the answer has not come till now, the chances of it coming anytime soon is diminishing faster. Have you understood the concept of pseudo force? Yes or no? Have you understood the concept of pseudo force? Chalo, I will solve it for you. The best way to solve this problem is sitting on the lift and chilling out. So I sit on the lift, down, and then I chill out. And then from the lift, what will I see? That this block will go down. Let me call the acceleration as A. And this block will go up with an acceleration A. That is sure. But that will only be visible when you are in the lift. Then I can draw the free body diagram, 2mg, mg tension T, but then I realize, oh God, I'm on a non-inertial frame. So I will have to apply 2 more forces here. Dung, 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 dung. On this block, the mass is 2m, acceleration is g by 2. On this block, mass is m, acceleration is g by 2. And as soon as I realize this, so basically what is going to happen is your g effective becomes g minus g by 2. Do we understand this? Yes or no? Huh? How many of you understand this? Girls, do we understand this? So now I can straight away write the answer. If you want, you can make the equations, but straight away I can write the answer. The acceleration A will be equal to m2 is 2m minus m1 is m into basically the value of g will become g is downwards and g by 2 is upwards. So it becomes g minus g by 2. So it is becoming g by 2. Do we understand this? Yes or no? We understand this? Divided by 2m plus m, that is 3m. So your answer would be g by 3. G by 6. 2 minus 1, 2. G by 6. This would be the answer that you would be getting, g by 6. Do we understand this? Anyone got this answer? Okay. Now I come to the real question. What is the acceleration of mass m with respect to lift? With respect to lift, it is going up and the acceleration is g by 6j. It is going up. Do we understand this? What is the acceleration of 2m block with respect to lift? With respect to lift, it is going downwards with an acceleration minus g by 6j. It is coming downwards. But what is happening with respect to ground? And that is why with respect to ground, you cannot make the equation because you will not be able to understand this. If I have to make the if I have to find the acceleration of m with respect to ground, how will I have to do it? I would have to put a L in between and I have to find it out this way. This will be the acceleration of mass with respect to the lift plus acceleration of lift with respect to ground, and you will see what is happening now. Mass with respect to lift is g by 6 in j, but lift with respect to ground is g by 2 downwards. So minus g by 2 downwards. So what you are going to see, it will be g by 6j minus g by 2j. So if I take the LCM, it will be minus 2g by j, or it will be equal to minus g by 3j. That means with respect to ground, M block is coming downwards. And it is difficult for you to imagine from the ground. And that is why I said that this equation has to be made with respect to the lift. Do we understand this, what I'm saying? Do we understand what I'm saying? What is the complication here? The complication is because of the lift also moving downwards. That is the complication. And you can see this block, which is actually moving upwards in the lift, accelerating upwards in the lift, with respect to ground, it is actually accelerating downwards. That is why you cannot make the equation from downward, because you will not be able to understand this. Anyways, let me find out the acceleration of 2m block with respect to ground. So how do I find it out? I put an L in between. So It will be acceleration of 2m with respect to lift plus acceleration of lift with respect to ground. In this case, both are negative, so they will just get added up, minus g by 6j minus g by 2j. You can add it up and you can get the answer to this one. This block will be moving downwards, but the other block is also moving downwards with respect to the lift. Do we understand how this is done? So in all the questions, what we have done, is instead of G, we have used what? We have used the value of G effective basically. And what is the value of G effective? If the lift is going upwards, the value of G effective becomes G plus A. If the lift is going downwards, the value of G effective becomes G minus A. Do we understand this? Why are you not getting answers? What is the problem? Can anyone tell me? Have we understood this concept or not? Have we understood the concept, beta? Boys? I don't see many raised hands on boys, so please tell me what is the problem. If you tell me the problem, then I'll get you the solution. If you don't tell me the problem, well, I can't give you the solution. I can't give you the solution unless and until I know what is the problem. Yes, anyone? Yes, tell me.
Sir, actually the concept is little confusion, sir.
What confusion you have? What confusion you have? You don't understand how do we apply pseudo force? Where is the confusion? That is what I'm asking. Where is the confusion? In which part is the confusion? Tell me, which part is the confusion? In this statement, where is the confusion? Tell me the confusion. I'm just combining two things. Just tell me the confusion here. In this, you don't understand pseudo force?
Sir, we understood the concept, sir, but solving the problems, in that we have little confusion. That's it.
What? What confusion in solving? In which problem you had a confusion?
Finding the acceleration.
How? Where you have confusion? You just have to apply an extra force, nothing else. What is the confusion? Just have to apply an extra force. I applied an extra force here. If you don't understand how I got this answer, I can write the equation. I can write the equation here. Sure, if you want me to write the equation, I write the equation. T is upwards, M2G is downwards, M2A is downwards. What is the equation of this block? Tell me. Tell me what is the equation of this block. I just applied an extra force, nothing else. Tell me what is the equation of this block. It is going downwards. Also remember that. Tell me the equation of this block. Tell me. I am not able to get you, but I hope you are saying this. M2G plus M2A minus T is equal to M2A dash. Yes or no? That is the equation. What is the confusion here? No confusion. Look at this blue block and tell me the equation of this blue block.
T minus M2G plus M2A equal M1A, T minus M1G plus M1A
Plus M1A minus M1A.
sir, minus M1A equals to M1A dash.
What is the confusion? Solve it. You will get this. There is no confusion. See, I just choose the short way. That instead of writing this equation, just put the value of G as G plus A and you are done. You solve it. Solve this equation, not a problem. Solve this equation, you will get the same answer. You will end up with the same answer. The only thing is, instead of G, you are everywhere getting G plus A. G, I mean, this is in bracket actually. So if I put a bracket, you're always getting G plus A. So I've just used that result, nothing else. I've not done anything extravagant. I've not done anything extravagant. I've not, and here, if you are finding difficulty in understanding this I can understand, because you might have forgotten how to find out the relative velocity. If you have forgotten this, you can go back and look at the formula and you will understand how I got this formula. But you can also make the equation here. Someone make the equation for me here. See, someone make the equation for me here. This is the pink block. Make the equation for this pink block. It is moving downwards. What is the equation of this pink block? Make it. So same thing. M2G minus T minus, this is 2M2. Make the equation. You will end up with the same result. 2M2G minus T minus 2M A, 2M into G by 2, that is upwards. That will be equal to 2M into A. Make the equation, it's the same thing. Just an extra force. Why is extra force creating so much of confusion? Why is there so much of confusion just because you have to apply an extra force? Should it be so much of confusion just because of an extra force? If you don't understand what is the magnitude of that extra force, well, M into A. If you don't understand what is the direction of that extra force, it is opposite to the direction of acceleration. These are the only two things that you have to understand. Everything is what we had done before. Nothing has changed. Nothing has changed. And nothing can change because the concept remains the same. Nothing can change. Now, if I put a question like this, this is M2, this is M1, and this lift is moving upwards with an acceleration A. And I ask you the same thing. What is the acceleration of the blocks with respect to the lift? What is your answer? The entire system is kept in a lift. What is the answer? What is the acceleration of the blocks with respect to the lift? A dash. Acceleration of the blocks with respect to the lift. Can anyone tell me? We have done a lot of difficult questions which were way difficult than this one. This question is we did in the, I don't remember even the class, third or fourth class probably.
M2 of G plus A by M plus M2.
Yes, that is the answer. That is the answer. Nothing has changed. The answer still remains. But remember, that is the acceleration with respect to the lift, not with respect to ground. So the answer is simply M2 into G plus A upon M1 plus M2. That is as simple as it gets. Don't have to do anything. Difficult? You can imagine it this way. If you're sitting in a lift, I told you pulling force divided by total mass. There are two pulling forces. One is M2G, which is the real force, which is pulling it downwards. One is because of the accelerated frame that you are there. So M2A. So now there are two pulling forces. Therefore, you have these two. That's it. Nothing else. Nothing has changed. Do we understand this? So this has gone up over saying bye bye, sir. Bye bye, sir. Bye bye, sir. Yeah, done, sir. We understand this? Okay, everyone? Okay, so in the next class, we'll move ahead and we will do some more problems on this. And remember, unless and until the lift goes up and down, the problem is very simple. But the problem may become a little bit different, not different, when the body moves like this. When it is going up and down, the problem still remains. You just put the value of G as G plus A or G minus A and you get your answers. Nothing much changes. So we'll do two more sets of problem. One will be on weighing machine and one will be on spring balance. We'll do in the next class. And then we will move on to one or two problems where the block will move like this, and then we will see what happens there. Remember, whenever you are making equation from a non-inertial frame, the only thing that is different is you have to apply one extra force. And that one extra force is a non-real force. That is the pseudo force. That is equal to F into MA. The direction is reverse. That's it. Do we understand this? Chalo then, I'll see you in the next class. Take care. Have a good day. Bye bye. God bless you all.
Thank you, sir.
Everyone understood this now?
Sir.
Take care.